This package where you guys are all testing motors, one of the things that I want you to be concerned with is just to look at the wiring diagram of the motor and to understand all the parts of the motor. We have many parts of the motor. Let me grab this other motor here real quick so I can show you a comparison. This is a Whirlpool direct drive motor. These are both washer motors, and they're both reversible, but they do things differently. This particular motor, a direct drive washer, goes clockwise or counterclockwise, and by the direction the motor goes, the washer can either agitate or to spin. And we have all these wires on here. One of the assignments that you had to do was to test the wires to figure out the run winding, the start winding. Then you had to figure out how to test it with a test cord, like to run it. Now if you look at this test cord, it's a regular power cord that has two wires on it, black and white, line 1 and neutral. But notice that we added 2 wires on line 1 and 2 wires on neutral, because the start winding inside this motor is not connected to the run winding. If we were talking about a dryer motor, the two of them are connected together, and so when you go to motors, you'll see that when you go on that one. But you could just use 2 wires on that motor. But on this one, you have to put 4, and the way you wire it is going to determine the direction of the motor. We need to use the diagram. So let's talk about this one, which is the washer. It goes under Cabrio, VMW. Now, not all Cabrios are the same either, because even some of them use this other style motor on there as well. When you guys get to motors, it's another motor I'm going to have you test. But this motor here has 4 wires on it. The difference is this motor doesn't have a centrifugal switch. That's what we have here on this motor, centrifugal switch. Okay? This motor here is controlled directly by the board. And what's unique about this one is when it agitates, the motor only goes one way and continues to run the same way, but the agitator that washes the clothes is going backwards and forwards, creating that agitation motion. That is done by the back side of this motor is connected to an actual transmission, you know, like a car transmission. And those gears are taking a circular motion and making it a back and forth motion. Now, how do they do that? How do they take something that's going like this and make it go back and forth? Well, that's been done for years. Y'all know how a train works? The locomotive on a train? Let's take a look at this. On a train, you have this one wheel that turns, and you have the shaft on it. And then they have a piston here. And on the front of the train, they have this big tank of water. And then this is the cab of the train back here, right? So they heat up the water creates pressure in a chamber and pushes this piston inside here out, and that causes this wheel to rotate. And then when it gets back over here, the piston goes backwards and forwards while this wheel is going around. So if I use the motor going around and I connect a gear to another gear here, I can create a backwards motion here. So they put in a washing machine, that direct drive washer has a gear called a sector gear, which is just a section of a gear. So if I'm going back and forth there, this gear is just doing what?
Agitating.
So I put an agitator on here, what's it going to do? It's going to go backwards and forwards, even though the wheel's doing circular motion. That's how the direct drive washer does. The motor, while it's washing, is always going in one direction, but through a set of gearing mechanism, we can cause the agitator to agitate back and forth. But on this motor here, on this VMW washer, first of all, we cannot connect this directly to power and make it work properly without the capacitor. This one needs the capacitor on it. But take a look at how they did it on the VMW washer. This is the motor right here, okay? And we have 2 windings. What does it say here? CW and CCW. So what is that?
Clockwise and the other one.
Clockwise and counterclockwise. So what we have on here is these 2 symbols right here. Does anybody know what those symbols are?
Oh, the triax.
Triax. Very good, triax. And we've talked about them in previous lectures that on the bottom of, I'll show you on the chart that I copied it from, but on the bottom of the chart has a list. Triax are like, remember we did those boards that had the relays with the switches on them? Well, triax are electronic relays. That power can't go through here unless I put a little voltage signal here, and then the switch closes and lets power go through. So watch this. In this motor here, we have a start winding, and we actually have two run windings for speed. We have a start winding and a run winding. That's on the direct drive washer. Let's take a look at the direct drive washer diagram for a second. I'm going to open that up. Give me a second here. Here's the direct drive washer. I know it's going to be sideways, but... So here's that motor here. It's going to be a little hard for me to rotate. Give me a second here. I had to do this the other day. So here's the direct drive washer motor. So we have a starting winding here, and then we have actually 3 speeds, high, medium, and low. But this starting winding, depending on which way we put power through, it determines if the motor goes clockwise or counterclockwise. Okay? But we have a start and separate run windings. But let's go back to that VMW motor. Which one of these is start and which one of these is run?
Start will be clockwise and counterclockwise will be run.
It's a good guess, but this is the start winding and this is the run winding, or this is the start winding and this is the run winding.
Just
What do I
confused.
mean?
Just confused.
This washer
Okay.
doesn't have a physical transmission.
Oh.
So we have no way to take a circular motion and create the agitation like the direct drive. So like some of these newer motors now, these higher torque motors, to create agitation, this motor goes like this and stops. Then the motor goes back and forth, and by moving the motor backwards and forwards, it causes the agitation. So we move the motor and stop it. We move the motor and stop it. We move the motor and stop it. Now, those motors cannot do that. You will burn the motor out. The motor's not designed to start and stop so many times. This motor's built differently. Okay? Now, how do they do that? It depends on how they run the power. So if I run the power through the motor by energizing A, follow what I'm going to do. Power comes in, goes through the red, and goes through the clockwise winding and out. That is my run winding, and that's going to be called clockwise. But what happens, and I'll change the color, is that we also send power through the capacitor through the other winding as a start winding to tell the motor which way to go.
But it's quick. It's
Well, this here, unlike these, which are mechanical relays, like
Right.
these relays on the board here, these are mechanical relays. This is electronic relay. Electronic relays allow for fast switching on and off.
Okay.
The mechanical relays can cause the on and off switching, but if it's switched on and off many times, it has a higher failure rate. It cannot handle like zoom, 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 zoom for 15 minutes. Where the mechanical relays can't do it, the electronic ones can. But watch this. We want it to go one way clockwise for 5 seconds, and then we want to go counterclockwise 5 seconds the other way. So what we have to do is we have to change the run winding and the start winding. So we turn off circuit A. Let me just erase this here. You know
So
what?
it switches the electricity back and forth?
So watch. So now what happens is we close circuit B, and we got power running through this relay, and we go through the counterclockwise winding and out, and then it goes this way through the capacitor as a start winding. So we keep switching these two electronic relays on and off, and it changes which winding's getting power. Now to ohm out this motor, it's fairly simple. We got a clockwise winding and a counterclockwise winding, which is pins 6 and 3. And they both connect to 9 like a common, almost like a dryer motor. So we're going to check 6 to 9, which is red and white. And we're going to check 3 and 9, which is yellow and white. And we've tested that motor. Now, we can bench test this on the table But it's not as easy as what we do here where we just hook up a test cord. Because this motor needs the capacitor for that start winding so we don't damage it. And we cannot like switch it backwards and forwards without a lot of wiring to make that happen. But if we took the capacitor off that washer and bridged it between pins 6 and 3, we take the capacitor, run 2 wires to those 2 colors, I can put power in 6 and 9, not 3, 6 and 9, but the way it's wired, it'll feed 3 as well.
You get your cranking out saying,
And it'll make it go what? Clockwise. Yeah. But then if I move 6 to 3 and keep that capacitor bridged, now I'm going to go counterclockwise. So I can mechanically make it go one way, and mechanically I can move the wires and make it go the other direction. So what I want you to do when you're testing that motor, it's telling you each winding's between 3 and 6 ohms. Check pin 6 and 9, or 3 and 9, and that's how you'll check those 2 windings. But if you want to bench test it on the table here, we need the capacitor off the washer, and we need to fabricate some wires that's going to connect our capacitor directly to our motor following this schematic, and that's how you would do it.
And that's the one that you've been working on, Josh? That Josh been working on?
No, Josh was working on the first one.
Oh, okay, that's this one.
He was doing this motor, but not 3-speed, 2-speed.
So this motor here, we need a capacitor.
You need the capacitor.
So to bench test, or
if you want to run it and actually see if it works.
And to check, but we can't own it. Can we own it out without the capacitor?
Yes. So we go back to the diagram.
And then you say between 3 and 6 ohms.
You're going to check between 6 and 9.
6 and 9.
Or 3 and 9. 3 is going to check this one, and 6 is going to check that one.
Got you.
And it's going to be anywhere between 3 and 6 ohms. Each winding is telling you right there. But you see, all of that I told you, no one ever told me. That's how this motor switches and creates agitation.
Yeah, I wouldn't never.
It's my understanding and interpretation. When I look at these things, I know what they are. I know how they work. Yeah. I look at this. When I first looked at this motor, I was like, why do they do that? Why is it like that? And then I said, oh, if they run through this one gets power directly, but this one gets it as like a start winding through the cap. And if they switch it, turn on B, it's going to change the direction of the motor. So this, you're like, look at, well, how, I don't see that. Obviously, when you're first looking at diagrams, you're not going to see it. But over time of using the diagrams, every time you work on a machine, every time you do something in this class, unless you're doing freon recovery, or you're doing brazing, or you're doing a gas stove, when you're out there working on the machine, I want you to have this diagram, and I want you to find every part and learn how that part and that diagram work together. That's the only way you're going to get good at troubleshooting and repairing. Okay? Any questions?
Oh, okay, that's pretty simple.
Go ahead and stop it.